Numerical statistics versus geometrical statistics, equally possible ensembles. We see 1 by 4 to the power n is so common in our real world, and whenever we see any formula, we will see that 2 to the power n, 2 to the power 2n, 4 to the power n, k to the power 3, some factors are always there where k to the power 6. These kind of factors we always find in our numerical calculation, and always these kind of things are in denominator or as a factors which talks about the possibility conditions. And whenever we try to put this kind of formula in our statistics, then we see that 2 to the power something, 4 to the power something, and these are so common, and the factors of 4, factors of 2 are so common. These kind of questions naturally arise, and 2 to the power n is a very fantastic condition for the power sets. And you will see wherever there are the series expansions, then we find 2 to the power 2n or 4 to the power n. These are very common in our statistical calculations. We will discuss about these things and the reason that lie behind these kind of conditions. First of all, we have to understand this triangle where one particular line segment which has a length 1 is taken as a standard, and when it is taken as a standard, that is the L is a given line segment, then we can see that 6 things are there: tan theta, cot theta, cosec theta, sec theta, cos theta, sin theta. All the 6 things are present there. When should we take this line segment as hypotenuse, and when should we take this line segment as base, and when should we take this line segment as perpendicular? This is the art of reasoning starts here. Now, whenever we talk about any ratio, what is that? That is rational number or irrational number divided by 1, whatever it is. But whenever we see any ratio, we should think it as ratio is not the number divided by number. No, don't think it in that way. If we think it in that way, then it is the numerical statistics. Numerical statistics think the ratio is a number divided by number. But geometrical statistics consider this numerator number is length of output and denominator is length of input. The denominator is the length of input, but the length are the numbers. These numbers are hiding the reality. The reality of non-commutative world is hidden through the numbers. Numbers abstract away the non-commutative nature of the world and converts every non-commutative reality to the commutative abstraction, which hides the concrete reality from our sight. We cannot see the reality because numbers hide reality divided by another hidden reality, ultimately stops our eye to see the real reality. Why should we think it as a length? We should think the real output. We should think about the real input. What is that real output and what is that real input? The real output is the line segment, the output line segment, and it is divided with input line segment. Now question is, how can we divide one line segment with another line segment? Its answer is already given in graphical statics, Professor Cremona and James Clerk Maxwell in 1843 to 1870. They have written extensively on this concept, where plus, minus, into, divide, equal to, powers are all well defined in graphical statics, Cremona and James Clerk Maxwell reciprocal diagrams. Even the matrix method of Cayley-Hamilton theorem at the time of the 1870 to 1880 were all discussed regarding these ratios as the output line segment divided by input line segment, and the concept of vector was generated on the basis of this. Gibbs designed the concept of vector from 1870 to 1920, and the concept was like this, where the commutative law never holds properly, and the non-commutative algebra started because world started to understand that the non-commutativeness is naturally natural. We have seen the non-commutativeness in quantum mechanics also, where the non-commutativeness is causing the measurement problems, and Heisenberg's uncertainty principle is also standing on the basis of this non-commutative nature of the nature. Now, ratio is the output line segment divided with input line segment. We should define the division as per the way Hamiltonian mechanics did and as per the way Cremona and Maxwell defined it. Division implies consuming the denominator object and creating the numerator object, whatever it is. Efficiency is defined as the output divided by input. Either it is energy, either it is work, either it is whatever, but efficiency is calculated with output whatever divided by input whatever. Efficiency is equal to, that is implies output whatever divided by input whatever. In the same way, the division is actually consuming the denominator and generating the numerator. Here we should understand that when a line segment is given, either we can consume it as the hypotenuse and generate the base, then that is considered as a cos theta. We can think cos theta as a operator, or we can think cos theta as an animal which eats the line segment as hypotenuse and returns the base line segment. Sin theta is another animal which consumes the same hypotenuse line segment and returns the perpendicular line segment. So cos theta is a efficiency kind of thing, sin theta is another efficiency kind of thing. For the same line segment, we can consume it as a base. Suppose that same line segment L is equal to 1 is consumed as a base, and the animal tan theta eats that same line segment as the base. It will not treat it as the hypotenuse. It will treat it as the food, which is a base type of food, and it will eat it, the base object as a line segment, and will return the perpendicular out as output line segment. So tan theta is another kind of animal. Similarly, sec theta is also a kind of animal which eats the same line segment L as the base as its food and returns the hypotenuse line segment, which is its output. In the same way, the same line segment L is not consumed as hypotenuse nor consumed as the base, but cot theta is another animal which eats that same line segment as the perpendicular and returns the base, that is another line segment. Cosec theta is another animal which eats that same line segment L, and it consumes this same line segment L as the perpendicular and generates the hypotenuse line segment. In that way, we can think that any line segment L that is given to us, any line segment L that is given line segment which is consumed as hypotenuse and generating the base line segment or perpendicular line segment as the cos and sine are the two different animals. In the same way, this same line segment is consumed as the base and returning the perpendicular object or the hypotenuse object. The same line segment is consumed as a perpendicular and returning the base line segment or hypotenuse line segments. Conditions depend upon the which kind of animal is eating it. The same line segment is eaten by 6 different kind of animals and returning 6 different kind of outputs, and when one output is generated, the other output is automatically complementary generated. Like when cos theta animal eats the line segment as hypotenuse, it generates the base output, but the complement line segment is the sin theta. Similarly, when sin theta consumes the hypotenuse, that animal returns the output as the perpendicular, but base is the complementary output. So one animal always returns two type of output. One is its direct output, another is its complementary output. For every of these trigonometry ratios, we can consider these trigonometry ratios as 6 different animals which eats the same line segment differently as a different kind of food, and the recipe is that food is taken and output is generated in two different ways. Either it is as the base and perpendicular, the outputs are either as the perpendicular and hypotenuse, or it is as a base and hypotenuse. In that way, we can consider these ratios as 6 different kind of animals. Now if we consider any number, say any number, whatever the number is, any number that is a real number. Now if it is a real number, then two conditions can occur. Either it is a rational number or it is a irrational number. Now it is rational number. If it is a rational number or irrational number. If it is rational number, then one kind of story can occur. If it is a rational number, then it is some prime number, prime divided by another prime. So rational numbers are the ratio of two prime numbers ultimately factored down to the prime numbers. Irrational numbers are just that irrational number by 1. So ultimately irrational number is that irrational number divided by 1. So ultimately the numerator is a line segment which has the length, and denominator is also a line segment which has a length. If we consider the length only, then we are hiding the reality from our eyes and we will get the partial story. If we don't hide the reality, then we will not take it as a length, we will take the real object as a line segment object, and the line segment divided with the line segment generates a triangle, because here we have seen that line segment consumed and two output line segments are generated whenever we take it as a trigonometry ratio. Now whatever it is, either it is rational or irrational, whatever the number it is, there are the situations like this. Either it is within minus infinity to plus infinity, either it is within minus infinity to plus infinity, or it is like minus 1 plus 1, either it is minus infinity to plus infinity, or minus 1 to plus 1, or it is like minus infinity to minus 1, minus infinity to minus 1, and plus 1 to plus infinity. It can occur as minus infinity to minus 1, or it is plus 1 to plus infinity. It can take any shape, either it is minus infinity to minus 1 or plus 1 to plus infinity. It can take any shape like these. Possibilities are there. So we are talking about the possibilities ensemble here. The possibilities ensembles talk in this way. So if it is minus 1 to plus 1, then it has the option like either it is using tan animal or cot animal, or either it is eaten by tan animal or cot animal or cos animal or sine animal. So 4 possibilities are there for this condition. If it is minus infinity to minus 1, then tan and cot are common, and we can see that it is either cosec animal or sec animal, and which can consume and generate minus infinity to plus infinity, which has the power to generate the infinity. Tan cot can generate any number. Cosec sec cannot enter into the minus 1 to plus 1 region. Similarly, plus 1 to plus infinity is also possible when it consumes as a tan animal, cot animal, cosec animal or sec animal, and minus infinity to plus infinity, that is also possible due to this tan animal, cot animal, cosec animal, sec animal. They have this power to generate this kind of number possibilities. So ultimately, whatever the case is, any number is ultimately going to give us 4 possibilities. Any real number is going to give us the 4 possibility conditions of the animals eating. 4 types of animals can eat the line segment and generate 2 other line segments. So from here the geometric statistics starts. The 4 possibilities open up. Now whenever a triangle is constructed, suppose as per the Thales theorem, suppose if the hypotenuse is given, we can get the x anywhere, and we can get the 90 degree if we travel on these circumferences. And if the triangle has a fixed sides angle, then we can get 4 symmetries. This one is one symmetry, this one is another symmetry, and this one is another symmetry where it's rotated 180 degree, and this one rotated 180 degree, and this one rotated 180 degree gives another symmetry. So 4 possible symmetries are there for every such animals eating. For any kind of conditions we can get 16 possible numbers, and that is the starting point of our geometric statistics. So whenever we see any statistical calculations with the numbers, we should think that that is hiding our reality, and the reality is hidden just because we have considered the if things are commutative, but in reality the nature is not commutative. Strictly, I repeat, nature is naturally not commutative, and every real number hides 16 possible equally possible conditions, and all these 16 equally possible conditions can occur with the least energy principle. So we have to study every kind of system with every plus minus into divide opens up four different possibilities, and all are equally valid, but the best one is chosen, the best one is calculated as per the least energy principle, and we have to revise entire of our statistical calculations as per the least energy principle, and considering that every number has 16 equally possible valid geometry of triangles. So we should not get confused that our number games will give us clarity about the world. We have to move towards the geometric reality. Since today's date, we have the TPUs, we have the artificial intelligence, we have the neural network. So why should we bother with the commutative algebra? We should move towards the non-commutative algebra, which can give us the more deeper reality and less chaotic analysis, which can give us more precise one shot solution for every kind of problems. Because we should not become lazy, machines are ready enough to do huge calculations, so why will we keep ourselves shortened with our analysis power? Our reasoning power should increase to the non-commutative calculations, and we should use the geometric statistics now instead of the numerical statistics. Thank you.